Welcome back to Miss Burkhart's math class. Make sure you have your notes with you and something to write with so you can take notes as you watch the video. And of course, as you know, make sure you're pausing the video in order to catch up with your notes. And also go back, watch any parts that you need to see again to make sure you fully understand the concept. So today we are starting a new unit on equations and inequalities. This is standard 6.13, which is to solve one-step linear equations in one variable, including practical problems that require the solution of a one-step linear equation in one variable. Today, however, we are going to start off by learning the really important vocabulary words and definitions that you're going to need for this unit. So let's get started. Now, as we begin our algebra in solving equations unit, and before we get into the vocabulary, I want to show you how you were actually solving equations way back in elementary school. Do you remember seeing problems like this in elementary school when you were first learning adding and subtracting and so forth? And when you either had a question mark or maybe there was a box to let you know here was the unknown number. Here's what the number you had to figure out. Or sometimes it was just a blank line. All of these indicated to you that here was the number you had to figure out. Well, those are all examples of equations, believe it or not. Now, however, since we're getting into more of the formal, if you want to call it that, algebraic equations, instead of using a question mark or a box or a blank line to represent an unknown number, the value we're trying to find out, now we're going to use a letter that we're going to call a variable. So, and we'll get to those in just a moment. Before that, though, equations. Equations are like, remember in science you had scales? Maybe you used it in elementary school, one like this. And in order to figure out the value or the weight of an object, you'd put one object on one side. And maybe you had those little gram weights or ounces or whatever, and you'd put them on this side, the other side of the scale, until it became balanced, kind of like this, until they were equal, right? That's how you knew how much that one object weighed, when it balanced or it was even. Well, that's what an equation is, and you've been doing them for a very long time. So let's look at this, and the equal sign. Think of the equal sign as like the stand, if you will, or the fulcrum of the scale. And what's on one side of the equal sign is equal to or balanced with what's on the other. So think of this. If I had an object that weighed 2 grams and another object that weighed 5 grams on this side, and then on this side, I had one object that weighed 7 grams. Well, it would be balanced, right? Because they both have a total value, in this case, of 7. So they're the same. What's on this side is the same as what's on this side. And it doesn't have to have the answer, so to speak, on the right side. Maybe it's like this, where I have one object that weighs 10 ounces on this side of the scale, and another that weighs, on this side, that weighs 6, and another object that weighs 4. Well, it would be balanced because they both have the same value. What's on one side of the equal sign is the same value as what's on the other. In this case, they both have 10 as a value. So those are some basics of the equations and what they mean. And we're going to begin learning the foundations of how to solve equations, really the steps that you're going to take in order to start to solve problems later on in your math career of problems like this. So some of the equations that we're going to be learning in this unit, you will be able to solve in your head, but I want to encourage you to make sure it's not just about getting the answer. It's learning how to solve the equations and the steps you need to take so that, because you're going to start using those very same steps to eventually solve equations that you see here, ones that you definitely cannot do in your head, right? So I encourage you to start learning and remembering that you're learning how to solve equations and the basic foundational steps so that later on, you're going to use those very same steps to solve equations like this. So now let's jump into the vocabulary. And these are on your notes. This is your notes. So make sure you have your pencil ready. And let's talk about this. I have an example up here at the top. 2x plus 5 equals 12. Let's look at our first word, an expression. And an expression versus an equation. An expression, as it says, is a mathematical sentence with numbers, variables, operators, and operators, by the way, are like the plus sign, minus sign, multiplication, division, and so forth. So an expression has all of these things, but no equal sign. An expression is a mathematical sentence, but with no equal sign. So in our example that we see here, an expression would be 2x plus 5. That's an expression. It has variables and terms and operators, but no equal sign. Another expression, notice I'm putting a comma here, would be 12. That's an expression on the other side here. Now, an equation, similar to an expression, is a mathematical sentence stating that two expressions are equal. So really, an equation is just an expression that has an equal sign. So that would be the whole thing in our example. 2x plus 5 is equal to 12. And the one way I find helpful to figure out the difference, an equation, if you look at the first part, EQ, is very similar in the beginning spelling of equal, EQU. Equation has an equal sign. Expression does not. Now let's look at a variable. We talked about this earlier, but a variable is just really a letter in the expression or equation that represents the unknown value. It's what you used to use when you'd see like the blank line or a box or the question mark. Now we're going to use a letter. Doesn't matter the letter, and it's always usually lowercase. So the variable in our example here is what? X. So we're going to write X. A constant, just like it says, is a number on its own, all by itself. So in our example here, a constant would be 5, but also 12. Notice I did not say 2. Even though 2 is a number, see how it has an x, the variable, attached to it? We'll talk about what that 2 is next. But the constant is just a number by itself, nothing attached to it. So our two constants in this example are 5 and 12. So let's write that. 5, and then we're going to put a comma and put 12. Those are our two constants in this example. Our next one, coefficient. Say that, coefficient. A coefficient is a number that is multiplied by a variable. Another way to think of it is, unofficially here, the number that's attached to the front of the variable. So a number that's multiplied by a variable or attached, that's what the 2 is. See how it's attached to our variable x? So 2 is a coefficient. It coexists. See the similarities? Coexists, coefficient, with the variable. So in this one, our 2 is the coefficient. Now, what does that 2x mean? Do you remember how I told you before that showed you the different ways to show multiplication other than our typical x? And this is why we're getting away from x as to mean multiplication, because now x is a variable. But do you remember the different ways? And we'd say it was, I'll put it down here. We had, we could use the dot to mean multiplication, like 2 times x. Or we could use parentheses, 2 and then the parentheses and what we're multiplying by it. Well, now, when you are multiplying a coefficient and a variable, another way to write that is just simply putting the number and the letter together, the variable together. This means 2 times x. So, let me write that a little better. 2x means the same thing as all of these. 2 times x, 2 in parentheses x. We don't tend to see these two very often, and that's why this means 2x means 2 times the variable x. So again, our coefficient is the number that is multiplied by the variable, or essentially think of it as attached to. Now, next term is term. A term in an expression or equation is a single number or a variable or a product or a quotient in an expression of sums or differences. So essentially, it's a number or product, quotient that is separated by a plus or minus sign, or could be an equal sign. So let's take a look up here in our example. So the terms in this equation are 2x. See how it's separated by the plus sign? So we have 5 and also 12. This has 3 terms in this equation. It's separate. So notice it's not 2 and x. It's not 2 separate terms. This is one term. This 5 is another term. And 12 is another term. So we're going to write each of those down. So we have 2x is one term, comma, and a 5 is the other term, and 12 is another term. So this equation would have 3 terms. Last is an inequality. We will get to those a little bit later, but figured we put this in our vocabulary words now. An inequality is a relationship that has an infinite number of solutions. So it's represented instead of an equal sign, it will have a less than or greater than or equal to or less than or equal to. So in here, this is an equation, but if I were to take that equal sign out and instead put the less than sign or the greater than, then that would be considered an inequality. So let's make one up here. So we can use the same terms. We can say 2x plus 5 is greater than 12. That would be considered an inequality. Now let's go ahead and put into practice some of these vocabulary words you just learned. We're going to do the first one together, and then you're going to do the second one on your own. So the first one, what is A? So look for A. What is the M called? The M is the unknown. It's the letter. So it is the variable. And then let's look at B. B points to the 9. Remember, the 9 is attached to, it's multiplied to the variable. So remember what that one's called? It coexists with the variable. So it is the coefficient. 2 F's. Coefficient. What about C? C is pointing to the 5, a number all by itself. What's that? The constant. It will constantly be 5, right? And is this an expression or an equation? It's an expression. Why? It does not have an equal sign, so this is an expression. And what are the terms in this expression? Remember, it's the items that are separated by the plus or minus sign, so the terms are 9m is one term, and the other term is 5. So this has 2 terms. All right, now it's your turn to try this one. You're going to identify what A is pointing to, which in this case is the 6, and B, and so forth. So pause the video and write your vocabulary words in here to identify each one. All right, so let's see how you did. A is a constant. Did you get that? Because it's a number by itself. B, pointing to the 2. Remember, that's attached to the variable. It's multiplied by the variable. So that is the coefficient. And then C, which is pointing to the Y. Did you say variable? And is this an expression or equation? It's an equation because it has an equal sign, just like it starts out with. And what are the terms? The terms are 2y and a comma, 6, and then last, 16. How'd you do? All right, so last ones, we're going to do this one together, and then you'll do number 4 on your own. So which one, now we're going in reverse. Which one is the variable? You see it's x, the variable is the letter. Coefficient, what is the number that is attached to or multiplied by the variable? And that is 5. What's the constant? Did you say 15? Good. It's not the 5 because see the 5 is attached to the variable, so that's the coefficient. Is this an expression or equation? Equation because it has a what? Equal sign. And what are the terms? 5x and 15. All right, now pause the video and you do this one. Go ahead and pause. So today you learned the important vocabulary words that we are going to need for this unit, like equations, inequalities, variables, constants, and so forth, and coefficients as well. So great job. That was a lot of vocabulary to learn at one time and to practice. So remember, make sure you have your notes, keep them in your binder, and bring them to class, and we'll see you next time. Bye-bye.